Let's now show how to draw a Turing machine for the language containing all the strings in the form a to the n, b to the n. For this, let's take an input, for example here triple A, triple B, and write this input on the tape. Then we have to show what will be the moves that will be done on the tape in order to reach an accept state or a reject state. Here, the first element in the tape will be A. We'll say, for example, that if we see A here, we will change it by another symbol, X for example, that will show that this A is already visited. And then we will move to the next symbol. This operation can be defined by the following transition. We will move from an initial state Q0 to another state Q1. We will read the symbol A on the tape. We will write on that place the symbol X and we will move right. So the tape will change in this way. And the first symbol, there will be the symbol X and the tape head will point on the next symbol on the tape since we made a move to the right cell. Now we will say that we will ignore this A. When we read the A, we will just move right. For the other A also, if we read it, we will move right. So we can add here a loop that shows that we will read the A, we will write the symbol A, so this A will not be changed. We will just move to the right position on the tape. Then after firing this transition twice, here and here, we will find the tape head pointing on the first B. In this case, for example, we will say that we will change this B by another symbol, which is Y, and move left. In this case, we need another transition that will go from Q1 to another state, denoted here Q2. We will write that we will change the B here by a Y, just to say that this B is already visited, and we will go left. We will go back left in order to look for the second A not changed here. And if we will find the A here, we want to go left and left and left until finding the X, because this X means it's the last A that was changed. So here we need this loop. If it's A, it will stay A and we will move left. We will fire this transition as many times as we have A's here in the left part. When we will point to this X, now we will move to the right one cell in order to find the next A to be visited or to be marked that it's visited. So here we will say that when we see the symbol X, we will just move right one cell and we will go back to Q0, from which we will do the changing again. We'll change this A by X and keep moving right until finding a B. We will change it by Y, or we will write a Y there and go left. Keep going left until finding an X and do the same work again and again. Note here that when we will take this way the second time or the third time, there would be some Y's, some symbols B that were already changed by Y. So in this case, we have to add in this loop. If we will find a Y, we will leave it there and we will move right. Again, when moving left, looking for some X, we may find some Y, which means that we had already changed some B by Y, and in this case also we have to add in this loop. If it's Y, we will just move left. So we'll do the same here. Keep moving left until finding X, then move right to change the next A, and following the same path here to change one A with an X, one B with a Y, one A with an X, another B with a Y, until finding all the symbols changed. All the A's will be changed by X and all the B's will be changed by Y. In this case, we will keep moving right until finding the blank symbol. In this case, we have written here from Q0. If it's not the case that we find A, we will find this Y. We will keep going right with each Y. If we see a Y, we'll go right. If we see Y, we'll go right. Until finding here the blank symbol, we will say that we will go to an accept state, Q accept. Only in this case, we will go to an accept state. Suppose here, for example, there still be another symbol A or B. There shouldn't be any possible move to an accept state from here. Also, note here, since n is positive or equal to 0, so epsilon will be accepted. We will add here from Q0 to Q accept. If we will find the blank symbol, we will accept the string epsilon. Now we can simplify the transitions. In the case, we will not change the symbol on the tape. If it's A and it will remain a symbol A here, we will write just A and then define the move right. If it's Y, it will stay Y and move to the right. We will have the possibility to write A left, for example. This means that if you see A here in this cell, it will remain A and we will move to the left. Instead, here, when we write A arrow X right, it means that if we see the symbol A, we will write the symbol X in that place and we will move right. So we can just write the transitions in this way. Now this machine lacks the reject state. We need to add a state that defines when the machine will reject the input. Recall here that if at the end of the computation we will find another A here that is not changed, in this case we will not accept the input. Also, if we find the B, another B, for example, 3 X's here, it means that there were 3 A's changed by 3 X's and 3 B's changed by 3 Y's. And here there is a fourth B. 3A with 4B is not accepted. So in this case also, we have to reject. Also, if we have double Y's and 3 A's here, 3 X's means 3 A's, double Y's means there were there double B's. So here, if we find this blank symbol, it means that there's a missing B here and we will not accept. Also at the beginning, for example, if we will find a B here, there will be a reject for this input. So this is the Q reject. It shows that from Q0, if we are looking at the tape and we will find a B here, so we will halt and reject the input. From Q1, if we see a blank from Q1 here, we are waiting for a B. We saw a symbol A, we changed it by X, and we are going right, looking for a B. If we don't find this B, we will find a blank symbol. It means that the number of B lacks one symbol at least. And in this case, we will halt and reject the input. From here, if we find that after all the Y's here, we still see a symbol A or the symbol B in the tape, this means that also the number of A's and B's is not good and we will halt and reject the input. Note that from Q2, we don't need to add any transition going to Q reject, since already when we came to Q2, we already went left. So we'll visit again a cell that is already visited and which will contain either A or Y, or X, of course. Also, from Q accept and Q reject, we will not have any arcs going out from these states, because if the machine reaches one of these states, it will halt directly, it will stop the computation. It will have its decision if it's accepted or rejected the input. In general, we will omit the state Q reject from the machine for clarity, for simplicity. We will not draw the Q reject, and implicitly any transition that is missing will be considered as leading to Q reject.